Good morning, Arnaldo, and good morning, good afternoon, good night to all of the participants. It's a great pleasure to introduce you to Professor Arnaldo Camuffo. He works in Bocconi in Milan at the Bocconi University as a full professor. And Arnaldo has done a lot of research the last couple of years into applying the scientific method PDCA, because we all have heard a lot about PDCA, but how to really apply this, that is quite something else. So Arnaldo has done over 100 companies he supported with startups. So he will go into this in his talk. So Arnaldo, the floor is yours.
Okay, good morning, good afternoon, or good night to everyone, and thanks, René, for the introduction. I will try to share with you a little bit of my experience and also the results of some research regarding the application of the scientific method, or PDCA, to entrepreneurial decision making. So to the decisions that entrepreneurs or even innovators, leaders within company have to make in order to explore new products and services. The first thing I want to do is, what is a scientific method, as popularized by Bill Deming during the 50s, and then as applied all over the world in obviously in lean companies. Well, if you want to go back to the essence, the scientific method is basically you start with an observation, you get surprised by something that you observe, you develop some understanding of that, and for simplicity we will call it a theory of what is going on. And then you would run tests, collect data, or run experiments, and you would draw a conclusion. And typically in the science world, in research, this would be something about the laws of nature or regularities, patterns related to a phenomenon. Probably the best, the most famous example of this is Galileo's moons of Jupiter. Galileo developed a telescope in the late 16th century, and he started looking at the stars and at the planets, and he discovered, or actually observed, that around Jupiter there were little other planets, satellites. And by repeated observation, he saw that they would be around Jupiter and stayed around Jupiter and move, basically revolve around Jupiter. So in this case, what did Galileo learn? Well, basically, he understood that there were some patterns, stars rotate around Jupiter, made association to other situations with similar characteristics or under similar conditions. If it is true for moons around Jupiter, well, it might be true for the Earth around the Sun. And so you see here, theory allows to correlate signals, then uncover mechanisms answering why, okay? And this then boils down to the whole theory of gravity, rotation around larger mass, as developed later by Newton. So this idea that you observe reality, you come up with what Bill Deming would call a plan, which is a reality, a theory, or a set of hypotheses. And then what you do is you run a test, okay? You run experiments of data to evaluate or disconfirm your theory or conjecture. Now, let me tell you this, in reality, in most of the lean world, obviously because of when it was born, and specifically Toyota, 1950s, 1960s, the big emphasis was put on facts, on reality, on Genshi Genbutsu, go to the Gemba, etc. But in reality, if you take scientists, many scientists do not need, or actually, are less interested in data and experiments than they are in the theory. Okay, for instance, Einstein developed the theory of relativity, and he was not interested in confirming or testing it. Actually, it got tested and confirmed several decades later with the Edelman experiment, because he was sure. Okay, because he knew from his conjectures, he knew from his observations that theory was true. Okay, he was pretty sure about the conjecture. So what I'm going to show you here is that in this idea of PDCA as iterations between the theory and data, between P and D and CA and back, we are probably overweighted the experimental part, but the experiments and data become relevant and meaningful only to the extent to which we have good thinking underlying it. So now let's try to turn this to the business world. What does it mean to apply the scientific method in entrepreneurial decisions? I'm going to focus here on what Shuk and Smiley ask, define a problem type number 4. Okay, where you have unknowns, you want to create a new market, you want to create a new product, or something like that. Well, also in this case, there's not much difference. You start with an observation or a problem, something that surprises you. And, if you take examples from very famous cases of entrepreneurial success, this is typically how, these big entrepreneurs started, for instance, unicorns like Airbnb or Uber. Then you move to theory, so you abstract and you generalize, and then you test it. But instead of concluding with, as scientists do, with something related to understanding, you actually conclude with a decision about an action. So you have an observational problem, you abstract, you theorize, you test, and then you act, and this action is about a business activity. Please note that in this case, PDCA means that this process is riddled with uncertainty. You really do not know, okay? So it's not an iteration cycle where you implement, it's an iteration cycle where you learn, because simply you do not know what is the problem you're trying to solve, and you do not know what is the solution to that problem. And therefore, you have to make decisions under uncertainty. So what is basically this decision? This decision is, should I commit resources now, today, to get something that I do not know and might be a value V in the future? Okay. So typically, what do we do, albeit in many cases implicitly or inadvertently? Well, we make a prediction, and we call it, for simplicity, V star, of something that we do not know, which is the future value of our idea, of our innovation, of our new product, or of our new firm. And we also set a threshold that we call V star. And then every time, we basically compare what is our estimate of what's going on, of the value that we're going to get, with a threshold, okay, with something that, for instance, might represent our best alternative option, or the amount of resources that we're willing to invest. And it is precisely the comparison between the estimate and the threshold that guides the iteration process. Now, what is theory? Theory is what links the V star, our estimates, with the true underlying value of something that nobody knows, okay? And the idea here is that if you have a good theory, you have a better V star, you have a better prediction. And the point is that everyone can make different estimates of star, because we can think of, or we can run different experiments, because every experiment is driven by what is our understanding of reality. And so it is very important to craft very well, our, Deming would call it our plan, our hypothesis, because they imply different experiments. The better we craft the experiments up front, and obviously the better we run it, the more powerful is our theory, and therefore the closer our estimate V star to the true value of the idea or of the product or service we are trying to invent. Now, it is very important to understand the relationship between the decision and the outcomes, right? So let's assume that our estimate of our new product or service is larger than what is our next best option. Okay, so it's the case in which V star is larger, V hat is larger than V star. Then in reality, what might happen is two cases, right? The first one is the case in which actually, the idea in reality has a value. We do not know it today, but we might discover it later. But later, we might also discover that we decided to go forward in exploring this idea, but actually the idea has no value or has a negative value. In that case, we would commit a type 1 error, a false positive. Vice versa, if we decided that our estimate of the value of the new product or service or of our new venture is lower than what we think should be, okay, it again, ex post, I can realize that, I was right because V was negative, or that I was wrong because in reality I missed an opportunity. So what we are conjecturing here is that the application of PDCA, or better, as we will see, the application of scientific approach, which is how we think that PDCA should be applied to new venture exploration in a digital world, is that it makes more likely that the hat larger than V star when the actual value is larger than 0 or positive, and it helps the decision makers to actually estimate something in a more conservative way when the value is actually negative. And so this would imply lower false positives and lower false negatives, and therefore better decisions and less waste built into the exploration process. How does this happen? It happens through better theories that link V star and V, and better experiments that make these theories more credible. I want to show you, as an application, the case study of Vimoto, which is one of the companies that we accelerated. Vimoto is basically a very simple company. I mean, an idea that exposed probably is a standard innovation idea or a standard innovation project or startup. Okay, they started in 2015 with the key idea was providing mobility services in large cities. They started in Milan, a team of 3, and the idea was to develop an app and obviously a set of electric scooter for scooter sharing for Milan. By the way, you can find the details of this case study in a recent Harvard Business Review article that we published. So their theory basically was very simple. Okay, we taught them how to think like scientists, and their theory was simple. Customers was their conjecture who value a motor rental service are young people with mobility needs and with some ability to pay. And they would say, what is our customer segment? It's college students. What are the source of uncertainty? Okay, so what is that we do not know? Well, obviously, we do not know if this is true. College students might like this, or college student might not like this. Okay, and here we are really stylizing for the sake of it. So their options was, okay, should I go for this idea? Should I pursue this idea? Should I explore this idea? Or should I simply don't do it and maybe do something else? And so you see here at the bottom of this chart, the scenario action pairs that actually says, okay, if I launch this idea and the students value the service, I get some value value V. But if I launch this and students do not value this service, okay, I will get a loss, okay? And if I don't do anything, let's assume for the sake of simplicity that we simply get 0 in both cases. Now, what is the expected value of the current actions, okay? And we actually taught them to think with probabilities, okay? We taught them to think through data, because science implies that you think through data and that you apply also mathematical and statistical tools. Well, at this stage, decision makers have prior probabilities, which is they have their own beliefs or information, and therefore they estimate an expected value, which is basically the sum weighted by the probabilities of the value of the idea. In this case, do not think about V and Z as monetary values. Decision makers are really interested in, at least initially, about a general sense. It's like a thumb up or thumb down, okay? But basically, the higher their prior, the higher their beliefs, the higher the information they have that leads them to believe that they're going to make a profit, the more likely is that the action is valuable, and therefore the more likely that they will pursue. In principle, they could simply decide now, okay, but instead Vimoto did something else. They said, no, I wanted to improve my prediction. I wanted to run an experiment. I wanted to buy a cheap option so that I'm a little more confident of what's going to happen. And so they developed a testable hypothesis. They asked, should I run an experiment to get a signal information that updates my probability? They developed a tested hypothesis. Their idea in terms of actionable metrics was that a lower idle time of scooters when parked near colleges for young students would be a good signal, okay? And then so they bought a number of those scooters and ran an experiment there. These experiments obviously allows to get more information. And obviously, if you have a certain number of data about how many scooters and what is the idle time, then you can factor into your decision rule, and you can simply update your probability. That might be higher than the probability you had up front, or lower than probability up front. This is typically a process of Bayesian updating, which is classic in statistical analysis. Now, note that it is important that there's also an expectations about future stages, right? So during the current exploration stage, not only the decision makers learn about what they are testing now, but they can also learn about something else, okay? They can incur in information and data and things that again surprise them, okay? So that the expected value of future exploration is what they think, it is this value minus the cost of exploration. So now, okay, you decide based on more information. And what are the decisions that you can take? Okay, you can go for with this idea, you can change the idea, i.e. pivot, or you can simply abandon. And therefore you make your comparison. Okay, so this is basically the situation. And by the way, this is very important to frame this because the way in which you choose the experiment and the way in which you actually run it makes a lot of difference because it really changes your decision rule, and therefore that's why behaving like a scientist might be more important. Now there are two ingredients of the decision. What is the information that you get now about your test? For instance, in the case, what is the information you get about the idle time of scooters parked near colleges? But also, what are the other things that you learn from running an experiment? Okay, and this obviously implies or is related to how you look at this information. So in this case, the decision problem that they had in front of them was, is the information that they got from experiment strong enough to make the launch of the idea valuable, okay, so that I can pursue? If not, okay, are the information that I'm getting sufficiently strong to do something else? If not, obviously you terminate. If yes, you pivot. So in this case, suppose that the founders of Imoto found not a much lower idle time of scooters parked near college. And so they started to say, well, my conjecture was not true, right? So I have now to think, maybe abandon. But if they have a strong enough theory, so if they have framed the problem correctly, and if they can correlate the signals, they can ask why. And the new theory here they came up with was that college students have predictable mobility needs. So they have routine schedule, and therefore they can use public transportation, they can use many other things. But instead, the service, the fact of renting scooters is ideal for unpredictable mobility needs. So you can revise your theory, and your target customers that is no longer students, but is young people with ability to pay, but with unpredictable mobility needs. So the original theory is now changed. And also, you can, for instance, in this case, what they learned is that big motorcycles, in that case, they were using motorcycles, had to be large and solid for safety reasons. But women didn't use them because they were too heavy. And so they pivoted, you see, to scooters parked downtown. No longer motorcycles, but scooters, no more parked downtown, parked near colleges, but downtown. So now you see, they have another decision problem, and they can actually enlarge their portfolio of experiments. What is the twist here? If you have a good theory, you have multiple actions. You have multiple options, and it's more likely that you will get a good idea out of it. So that's how you are going to do better. So summarizing, with a better theory, broader theory, with more ability to connect and relate the signals, and with better experiments, you're going to be better off. And this is basically the implication of scientific approach. What happened to Imoto? They committed to a business model that uses scooters and targets young professionals in large cities. They scaled up the business, extending it to Turin, Genova, and even the Italia Riviera, Portofino. And they exited in 2021 with a sizable exit, and they were acquired by Helbitz. So what is basically the idea? If you are a non-scientific decision maker, you are going to simply go and test, a little bit like the Lean Startup method, get out of the building, fail off and fail quickly, and with somewhat a blind search process. But instead, if you spend time crafting well your problem and developing your theory, you see more actions, you elicit better signals, and you can correlate this information across stages. What are the effects here? You terminate more because you realize earlier that your idea might be wrong. You pivot more efficiently. You do not do 20 pivots randomly, okay, hoping that you sooner or later you will get somewhere, but you choose precisely, the pivot that is most promising based on your theory, and eventually you get better performance. We did research on this, okay, and the research that we did was a set of randomized controlled trials. Now it's 800 startups around the world, and basically we treated them through a training program. Basically what we did to all firms, we offered a free of charge strategy training course with the same number of sessions, same topics. To the treatment group, we also taught them how to think like scientists, basically do PDCA with this new under uncertainty type of decision-making twist. And this is basically the scientific treatment, which is precisely along the lines of PDCA. This is the timeline. And we collected data over time. So we followed the startups for more than 1 year through phone interviews and details. And here is the results. You see here what they do. I mean, the treatment, the blue bars here that are the scientific entrepreneurs, they pivot more selectively, okay? They do less pivots than the controls, okay? And by the way, they also exit more. They commit fewer false positives. And in terms of revenues, okay, over a 1 year time period, you see also a significant difference in terms of revenue. What is the practical value of this? Well, for instance, if you talk of the application of this scientific approach to an incubator and accelerator, you get a 10% waste reduction in innovators' effort. So you basically avoid pursuing one unpromising project out of 10. This is also applies to corporate innovation, innovation contests, hackathons, etc. An enterprise accelerator with a capacity for a 100 project and monthly intakes of 10 startups and a 1 year program to accelerate startup would get a faster acceleration time, more efficient use of resources, more than 10% without considering faster turnover, so less waste. You have more likely and more focused pivoting. You double the probability to early adjust the project. You get between 50 and 200% reduction in convergence time, so shorter throughput time of projects, fewer and better pivots, and more effective and efficient acceleration program. In terms of performance, 3 times the amount of cumulative revenues and twice the probability of higher than average return projects. We are proceeding on this. We have a set of other randomized controlled trials field experiments going on around the world with the Indian School of Business, Hyderabad, India, with the Polytechnics in Milan and Turin, with Sujeco in Tanzania, in the agri-food business, Shanghai University in China, Uniandes in Bogota, Colombia, the Netherlands, Rotterdam School of Management, City University in London, and then another round in Milan. All these things are also available in a massive online open course on Coursera, where you can actually learn how to apply a scientific approach to innovation management. One thing I would like to comment on is, and Renee, you will tell me how good I'm doing time-wise, is how does this relate to the Lean Startup? So what does the Lean Startup method suggest? It suggests that startups should learn about the customer problems and needs. They should obtain feedback, build a minimum viable product to test the demand, and then simply iterate. Okay, iterate as quickly as possible. So what is the Lean Startup method all about? It's about quick iterative learning through experimentation and feedback, and quitting or pivoting when the original idea proves to be untenable. Now, how are we complementing this? Well, we are complementing this in the following ways. First of all, we try not to overemphasize quick learning loops. Rapid iterations of the build, measure, learn cycles, the so-called fail often, fail quickly mantra, at times might seem a blind search process. Okay, we've seen time and again that the fact that you do not spend time actually really understanding, really making the part that we call a theory crafting, it brings you to experiment randomly. But random experiments are, of course, a potential way to learn, but it's a very wasteful way to learn. So I think that we should countermeasure this by getting more focused and through a better guided search. By the way, we also posit that the perfect scientist. Okay, so and we've talked about this with several entrepreneurs and also with several owners of unicorns, etc. I mean, their idea was, and the idea is, okay, if you can avoid experimentation, if you can run conceptual experiments, if your thinking is good enough, in abstract, in principle, okay, experimentation is simply waste. Okay. Now, of course, reality is much more complex than we think, and we all have assumptions that need to be tested. But overemphasizing the fact that you run experiments for the sake of running experiments, that's not appropriate. Second point is build, measure, learn cycles. Learning cycles without decisions and decision rules. Okay, what are the decision rules? For instance, in many cases, we have seen also corporate innovation programs where the Lean Startup method was applied, but for instance, no threshold or no decision rules would be set up front. And so basically, if you do not set up front the decision rules, how can then you actually have a standard or a baseline to learn and make decisions? If you simply go through the cycles without setting decision rules and therefore clarifying what are your beliefs, what are your assumptions, what are your thresholds, what are your confidence levels, well, the fact that the priors and posteriors remain implicit implies biases. Okay, the last information you get is the information on which you will make your decision. Then there's primacy of action over thinking. The idea of get out of the building. This is important, obviously, but it might lead also to superficial learning. Okay, because you do not spend time enough to really understand why are you getting out of the building and why you're doing that. And then another thing that we saw is that the idea of running experiments more rigorously, instead of simply running A/B or ABC tests without clarifying what is the cost benefit analysis underlying the investment and what are actually the metrics that you're using. And for instance, we found the concept of actionable metric somewhat vague. In science, we use these two constructs that are measures validity and measure reliability. Okay, and there are numbers of things that are important to consider. So in the end, I think that also in terms of entrepreneurial ideas, there's a different type of ventures, different type of ideas. And really the method that you wanted to use, the different versions of the PDCA you want to use are actually different according to what you would like to perceive. And we think that when you wanted to really create a new market and you are thinking about really exploring unknown unknowns, you have to have a full balanced PDCA approach and give a lot of emphasis on theory.
Thank you, Arnaldo.
Okay, guys, thank you. Thank you, Arnaldo, for sharing. Thank you, René.